everyone. For the region bounded by the graphs of y equals x squared minus 1 and y equals x plus 1, we're going to find the volume of the solid generated by revolving the region about the x-axis. So since we don't have the bounds on our x yet, let's go ahead and find the intersection points by setting our two y's equal to each other. So we're going to get x squared minus 1 equals x plus 1. Therefore, we would get x squared minus x minus 2 equals 0. And you factor, you get x minus 1 times x plus 1 equals 0. So we have x equals 2 or x equals negative 1. Now let's do some graphs here. If I graph this, I'm going to do little graphs. This one, the first one, the red one, I'll call it, is a quadratic that shifted down by 1. It's going to cross here at 1 and negative 1. So there's that, something like this. And then this one, our linear, x plus 1, so y-intercept at 1. We also know it intersects at 2, where x is 2. This is 1, so 2. If I substitute in 2, I'm going to get 3. So I'll put this at 3. So it intersects there. So it goes through like this. Intersects at negative 1 and at 2. So basically we have this piece right in here. All right. So the shaded region that's bounded by all of this is going to be this area here. Now since it revolves around about the x-axis, so basically if I draw my line again, so let's put that in green. So something like this, right? This quadratic here I have, and I go up this way, and it's going to go through 3 somewhere. So basically this piece can be, since it revolves around the x-axis, I can move this piece in here up. So I can move it up like this, right? And so then I can just take this area in here. Well, not the area, the volume. All right. So basically what we're doing is we're going from, and I'm going to take this from 0, from negative 1 to 0, has this part, right? Then from 0 to 1, then we have to 2. So at 2, it goes up to 3 here. All right. And so that's a straight line. And then it curves back down to 1. Then we have this piece. So basically the area I'm looking for is this area in here, or the volume. All right, so this is your 2. So when I set up my integral, what I'm going to do is write it as our volume is pi times, and we're going to go from negative 1 to 0. Now the upper bound here for this one is this green, this purple here, which is actually this piece in here, right? So basically, so you look at your upper bound, and that is your x squared minus 1 dx. Now for this piece, this shaded region, it's enclosed by this line here from 0 to 2. So we're going to write from the integral from 0 to 2, and the line is x plus 1. All right, but that includes this area when I set it up this way. So I'm going to have to subtract 1, this is pi, 1 to 2, and this area here is the upper bound to this shaded part is your x squared minus 1. So that's how you set it up. All right, and then from there we can just simplify this by expanding all of this out. So that's what I'm going to do next. I'm going to just expand it. We're going to have this equals pi, and we're going to go from negative 1 to 0 of x to the power of 4 minus 2x squared plus 1 dx. And then for that second integral, I had pi times the integral from 0 to 2. And this one was just x squared plus 2x plus 1 dx. And then we subtract that little bit that we have to subtract back out. That was included in this piece. So that's 1 to 2, x to the 4th power minus 2x squared plus 1 dx. All right, so let's integrate all this. This is going to be pi, and then we're going to have 1 divided by 5x to the power of 5 minus 2/3 x cubed plus x. This is from negative 1 to 0. Plus pi, this is going to be 1/3 x cubed plus x squared plus x. This is going to go from 0 to 2. And then this one's going to be minus pi. And we're going to get 1/5 x to the power of 5 minus 2/3 x cubed plus x. And this is from 1 to 2. All right, so let's substitute in some more values. When you substitute in 0, you're just going to get 0. So we're just going to substitute in the negative 1. That's going to give you pi times 1/5 minus 2/3 plus 1. Because remember, you're going to have 0 minus that. So I already did the sign change there. And then for this piece, we just need to substitute in that 2. So that's going to be pi times 8 divided by 3 plus 4 plus 2. And then for this one, we're going to get minus pi times 31 divided by 5 minus 2/3 times 7 plus 1. All right, and I already did a lot of the math here. You can use your calculator if you want, but basically you're going to get 100. The common denominator is 15, so you get 100 divided by 15 pi, and that's going to equal 20 divided by 3 pi. Thank you. Have a nice day. Bye-bye.